Hi, I'm Arpan and I'm an application engineer at Materialise. Today I will show you how to easily create a 3D model of an abdominal aortic aneurysm from a CT scan using Materialise Mimics inPrint. Aortic aneurysms grow over time and can eventually rupture, which may prove fatal. The first step of this workflow is the creation of the region of interest, or ROI, which covers the blood volume inside the aorta. Then I will show you how you can edit and refine this ROI. I will then create a second ROI which covers the aneurysm, followed by editing and refining this second ROI. Once the two regions of interest are correctly defined, I will create 3D parts based on these ROIs. I will then show you how to edit these parts using our simple editing tools. The model will be finalized by placing a label on it and making it ready for printing. To define the region containing the lumen of the aorta, open the thresholding tool. With this tool, you can define a threshold containing all the voxels within a certain interval of gray values. The gray value is proportional to the density of the tissue, and the tool allows you to select all the structures within a certain range of density expressed in Hounsfield units. Based on the interval that is currently set, you will notice that certain regions have been colored on the 2D viewports and the corresponding 3D preview generated. Move the bars and adjust the minimum and maximum threshold value to define the range that best captures the blood in the aorta. In this case, that would be approximately 175 to 1603 Hounsfield units. Also, we can set the name of this region to Aorta. Use the bounding box to reduce the working volume of the tool. When doing so, scroll through the slices of the dataset and look through the different image views to verify that you are not excluding any areas of the aorta. When you are satisfied with your selection, click the green tick to accept your selection. Upon selecting the green tick, two things will happen. First, a new region of interest called Aorta will appear in the ROI tab. Then the software will automatically jump to the next step of the workflow called Edit ROI. You will notice that our ROI covers the aorta, but it also contains a lot of unnecessary anatomy. The tools in Edit ROI will help us clean out our aorta to better define the intended region. The first editing tool we will use is the Isolate tool. This tool helps us separate any non-connected structures from our intended region. When you open the tool, it prompts you to click on the structure you want to isolate. Click on the blood volume in the aorta, either in the images or in the 3D preview. The selected structure becomes green. Once you're satisfied with your selection, click the green tick and all the non-connected structures will disappear. Now you want to separate the vertebrae, hip and kidneys from the aorta. To do so, open the Split tool. The Split tool asks you to define a foreground and a background. The region corresponding to the foreground will be kept in the ROI, while the region defined as the background will be deleted. Hover your mouse over the sagittal window and hit spacebar on your keyboard to view it in full screen. Scroll through the slices until you reach a slice that shows the connection between the aorta and the vertebrae. You can adjust the diameter of the brush with this handle. Roughly highlight the aorta by left-clicking and dragging your mouse. Then select the background option in the Split tool and highlight the vertebrae. Click the green tick and let the algorithm do its magic. This should separate the aorta from the vertebrae and hip, but the kidneys might still be included. To separate the aorta from the kidneys, perform the operation again. This time, view the axial window in full screen and highlight the kidneys as the background. Once you are satisfied with your selection, hit the green tick and this should separate the aorta completely. Hit the red cross to close the tool. The region of interest is now well defined. However, in some areas it needs to be fine-tuned further, such as here and here. These parts do not accurately represent the blood volume of the aorta. To do this, we will manually delete areas from the ROI. When you click on these areas in the 3D preview, the image views will also update in that area. Select the brush tool and set the mode to erase. Adjust the diameter of the selection tool with this handle. Left click and drag your mouse over the unwanted area. And it will be removed from the ROI. Scroll through the slices to completely erase all unwanted area further up at around slice 314.6. Once you're satisfied, click the back button. Using the split tool and manual editing might result in the creation of some disconnected structures. As a final step, perform the isolate tool once again. Click on the aorta to get rid of any disconnected structures. Your aorta ROI is now well defined and ready to be converted into a 3D model. The next step is to create a region of interest that covers the aneurysm. To do this, we have to go back to the first step, create ROI. To define the region of the aneurysm, select the 3D Interpolate tool. This tool lets you locally color in your region of interest on the images. You will need to manually go through the slices and highlight the region that contains the aneurysm. However, you don't need to mark every slice. You just need to mark a few slices and the software will automatically interpolate through the missing slices in between. Select the brush tool. Ensure the mode is set to positive and select the operation as add. View the axial window in full screen. Scroll through the slices until you reach a slice that shows where the aneurysm first starts to appear. This is approximately slice 323.7. You can adjust the diameter of your brush with this handle. Left click and drag your mouse to accurately draw the region of the aneurysm on this slice. Include the aorta in your selection. We will remove it later. Scroll down approximately 5 to 10 slices and mark the clotted area in your axial image again. Repeat the marking until slice 260. You will notice that your selection is automatically being interpolated through, displayed by a green color. Your selection is also visualized as lines in the two other views and a 3D preview. This can help check whether the intended region has been well captured. In case you would like to erase part of a marking, click on the negative button in the mode. Then left click and drag the mouse on the area of the marking that needs to be removed. Once you are satisfied with your selection, Click the green tick and a new region of interest called New ROI will appear in the ROI tab. Double-click on this to rename the ROI to Aneurysm. Also, click on the color option of the Aorta ROI and change its color to red to better distinguish the two ROIs. The aneurysm ROI is created as a solid one. We need to edit it by removing the region of the aorta that passes through this aneurysm ROI. Since we have the aorta ROI already defined, we can simply subtract it from the aneurysm ROI. Select the subtract tool. This tool helps separate one ROI from the other. Under selection, select the aneurysm ROI, and under ROI to subtract, select the aorta ROI. Click the green tick to perform the operation, and you should have a better defined aneurysm ROI. As a final step, perform the isolate tool to get rid of any disconnected structures. Ensure the selection is aneurysm and click on the region that needs to be kept. Your aneurysm ROI is now well defined and ready to be converted into a 3D model. To create a 3D model from the ROIs, click on the Add Part button of the workflow toolbar. Click on the tool Solid Part and ensure both ROIs are selected. Click the green tick to perform the operation. Once this is performed, you will notice that the ROI tab closed and the Parts tab opened. Two new paths have been created, Aneurysm and Aorta. The software also automatically jumped from the Create Part step to the Edit Part step of the workflow. We now have 3D parts created for our regions of interest. We need to edit these parts before they can be finalized for printing. Often generated parts have rough features on their surface, such as holes and peaks. To get rid of these, we will use the Smooth tool. Under Selection, ensure that both of your parts are selected. The detail determines the size of the triangles that will be created on a new surface, while the fill cavities under determines the size of gaps in the surface that are filled after smoothing. In this case, set the detail at 0.5 and fill cavities under at 1. Click the green tick to perform the operation. You will get a much better looking part with a smoother surface. The generated aorta part represents the blood volume inside the aorta. We want to create a hollow part which represents the walls of the blood vessel. To do so, we will use the hollow part tool. Set the direction as outward and define the thickness as 1.5 millimeters. Click the green tick to perform the operation. This will result in a hollow part with a 1.5 millimeter wall thickness. We could have created this hollow part in the previous stage, creating 3D parts. However, that would result in a very roughly created hollow part. By performing a smooth operation and then creating a hollow part, we get a better defined hollow model. To check whether the model accurately represents the patient's anatomy, scroll through the slices in the 2D views and look at the contours of the newly created 3D model. Next, we will use the Cut tool to open the endings of our aorta model. Under Selection, ensure that only aorta is selected and the method is set to remove inner. In the 3D view, click around the endings of the aorta to create a closed polygon. Click the green tick to perform the cut. Repeat the operation to open up all branches. When all extremities are opened, click on the red cross to exit the tool. As a last step of the editing process, we will use the Isolate tool to remove any unconnected structures from both parts. Select the aorta under Selection and click on the aorta model. Click on the green tick to perform the operation. Perform the same operation on the aneurysm part. The part editing process is now complete. The last step of the workflow is the preparation of the models for 3D printing. Click on the Prepare Print button of the workflow toolbar. In this step of the process, you can add a label on your 3D parts for traceability purposes. Use the Label tool to do so. You can select the method as inward or outward. In this case, we will select it as outward. Define the text of the label in the text box and set the height as required. Hover your mouse into the 3D viewport. You can right-click to rotate and use the scroll button to pan the 3D model. Choose the place where you want to label the part and left-click to apply the label. The label will now appear in 3D as part of the 3D model. The very last step before exporting the models is repairing them to ensure a successful print. Open the Repair tool and wait for the software to analyze the part. The Diagnose box will give the successful message, Ready for printing. Ensure you perform this for both parts. You can now close the tool. Your models are ready for printing and you can now export them as an STL file. I hope this video was useful, and in case you have any questions, please contact us using the contact details mentioned on this screen.